Okay, today we're going to do the second part of well, actually, this whole week, the next couple of lessons are about solving integration using like methods, specifically making substitution. So, if you thought about the last class when you took the integral, when you did du dx, the du over dx, there was also always something in the denominator. So it was du over 5, du over 7. So, the next set of problems. Here's an example. These look weird because it's like the product rule, but you're saying, like, wait a minute, like, how am I going to take the integral of this, or something like this, or something, this weird, like, expression. Well, in these problems, it turns out that when you take a derivative, it's going to knock out the other term that's there, and so it's not a coincidence. I've also uploaded some problems from SL. It's very clear. So immediately you look at this, and you're like, x squared, the derivative, that knocks out that 2x. If you let 2x squared minus 4x minus 5, let that be the substitution, and you take the derivative, you have like 2x minus 4 in the denominator. That's going to knock out the 3x minus 6. Same idea here. If you let sine theta plus 5 be the substitution, the derivative of that knocks out the cosine. So in these three examples, let's take a look at these. So the first thing is, so you're going to take u to be x squared. So you have du over dx equals 2x. That means that du over 2x equals dx. Now let's put it back in here. We take the integral, you say, I'm still in x world, but e to the u times du over 2x, these cancel out. And now your whole integral is in terms of u, e to the u plus c, final answer, e to the x squared plus c. Let's look at the next one. 3x minus 6 divided by x squared minus 4 minus 5 dx. What are you going to do with that? Okay. Take the denominator. Now, if you notice, I said the first one was the exponent. Next, we're going to look in the denominator for where we substitute, or the expression with the higher exponent. So we have u equals x squared minus 4x minus 5. I'm going to take the derivative, du dx equals 2x minus 4. Which means that du over 2x minus 4 is equal to dx. Let's see what happens. Let me plug this back in. Well, I did get rid of my x. I have my u in the denominator. I have my du, and it's like, oh, this is going to cancel each other out, because both of these, let's say I didn't know, you can factor. And then you discover that the x minus 2's go out, and you're simply left with 3 over 2u du, and that's just basic. It's just, 3 over 2 ln of u plus c, final answer, 3 over 2 ln of x squared minus 4x minus 5 plus c. Let's take a look at the last one. The integral of cosine theta times the square root of sine theta plus 5. When in doubt, the next piece of advice, take out the expression from under the radical and see what you can do. But I want you to be detectives. I want you to be very observant. I want you to say, oh, you know what? The derivative of sine is cosine, and the derivative is going in the denominator under the dx, the du. Let's see. Du over d theta is equal to cosine theta. Let's substitute everything back in. So that means du over cosine theta equals d theta. Let's substitute everything back in. We have the integral of cosine theta, integral of u, du over cosine theta. Nice. So we have the integral of radical u, that becomes 2/3 u to the 3/2 plus c. Final answer, 2/3 times sine theta plus 5 to the 3/2 plus c. So once again, we've figured out a substitution. Once again, where to look? Look in the look in the exponent. Look in the denominator. Look under the radical, under a radical. But specifically, you're looking for the form. You're looking for this form of, it's almost like the integral of f prime of x. It's like g of x, and then f of g of x. Once again, it's this function inside of something, and the derivative will knock out this other term. So that's kind of what you're looking for. But you're like a detective. Okay. What other types of substitution are we going to have to do? Well, if you notice here, we got rid of this whole expression under the radical, and it just became u to the 1/2. So you might see problems like this. You might see, take the integral of x radical 4x minus 1 dx. Okay, now you look at this and you say, well, wait a minute, the derivative of 4x plus 1 is not knocking out that x, right? So what do you do? Well, nowadays they give you the substitution. So they will say, let u equal 4x minus 1. Once again, we're going to substitute under the radical. We're going to see what happens here. Well, you notice that if u equals 4x minus 1, that means that u plus 1 over 4 equals x, right? And du over dx equals 4. So du over 4 equals dx. Let's put this back together again. This is the important part. This is what we're interested in. Let's see what happens when I substitute this. So I have the integral of the radical u. I have du over 4. What's going on here? Well, this is u over 4 plus 1/4. Now, why is this convenient for us? Well, because if I just distribute the u through this, I simply have, we're just back to basic day 1 of integrals. Let's take a look at what happened here. So this is u to the 1/2 plus u to the 2/3. So this is u to the 3/2 over 4 plus u to the 1/2 over 4. Oh, did I put the 4 in there? Nope. And then suddenly we've been manipulated, and suddenly this is we're back to day 1. Well, let's take a look at this. So let's just clean this up. So it's 5, what does this become? It's a 2/5, so it's 2 over, what can I do with this? How can I make life easier? I want to think about that. Well, first of all, let me pull out the 4. So it's 1 over 16 integral of u to the 3/2 plus u to the 1/2 du. It's 1 over 16. What's the integral? This is 2/5. U to the 5. No, yeah, u to the 5/2 plus, what is that? 2/3 u to the 3/2 plus c. Final answer, what is this? 1 over 40 u to the 5/2 plus 1 over 24 u to the 3/2 plus c. And then let's put this back in there. What do we have? 1 over 40, open parentheses, 4x minus 1 to the 5 over 2. plus 1 over 24, 4x minus 1 to the 3/2 plus c. It's a little cumbersome, but the idea is you're going to be given the substitution. Here's a problem that I found in the book. Integral, and then the last one, let's do one that's really, let's try another one. The integral of radical 2 to 2 of x squared minus 1 to the negative 3/2 dx. So you look at that, and what do? Well, I'm going to give you the substitution. I'm going to tell you that x equals secant of theta. Now this is in the book, you can follow along. X equals secant of theta. So we have a couple of substitutions to do. First of all, I'm going to replace this. So it's going to be secant squared minus 1 to the negative 3/2 c. I have to replace the dx. So dx over d theta is equal to, look in your formula, look at secant theta, tangent theta. And then I have to take care of those limits, right? But it's a little weird because it's backwards. You just have to pay attention. So if x equals radical 2 equals secant theta, then radical 2 over 2 equals cosine theta, and that means theta is equal to pi over 4. Now let's look at the upper limit. If 2 is equal to secant theta, that means 1/2 is equal to cosine theta. That means theta is equal to, what's that one? Pi over 3. So let's put this all together. So we have secant theta minus 1 to the negative 3 over 2. We replace dx. We say dx is equal to secant theta plus tangent theta d theta. Let's put that here. Secant theta, tangent theta, d theta. And then let's replace our two limits. Pi over 4, pi over 3. Now, this is, once again, this gets a little cumbersome. What can you do with this? Well, you know that secant theta is tangent theta, right? So I'm going to leave this off. I'm going to use my letters, tangents and cosines and secants. So I know that this is tangent squared to the negative 3 over 2. I have 1 over cosine, and I have sine over cosine, right? So I have tangent to the negative third times 1 over cosine times sine over cosine. So tangent to the third, this actually is cosine to the third over sine to the third times 1 over cosine times sine over cosine. Let's see, what am I left with here? I have cosecant times divided by times a cosecant squared, right? And then, is that something I know? Let's see. Okay, and then the last thing, what do they do here? It's cosine theta times cosecant theta times 1 over sine theta, which gives us cotangent theta cosecant theta. Are you going to get anything that's difficult like this? No, but it's follow through the book and see where they get this from. Well, let's finish this up. Let's finish this up. The integral of cosecant theta cotangent theta is, what is the integral? What is that? It's negative cosecant. Well, the integral, this is negative cosecant theta. Do I have any numbers here I need to take care of? No, I'm in good shape. And so, simply put, we have negative cosecant theta from what? From pi over 4 to pi over 3. We have, let's see, so this is negative 1 over sine of pi over 3 minus negative 1 over sine of pi over 4. What is the sine of 60? It's radical 3 over 2 minus, and then sine of 45 is radical 2, so it's plus 2 over radical 2, and that's the answer. There seems to be a mistake here, but I can figure that out later. Find my mistake. Last problem. Last question. Last question. This is in the book. This is question 19b, G2. And the question is, sorry guys, it's the integral of 6 secant to the 6th of x over 4 times the tangent of x over 4 dx. So the question is, how do you deal with this? Well, once again, the IB problems aren't that difficult, and if there is a substitution, they're going to give it to you. Now, my recommendation in this case is turn everything into, I immediately thought, the derivative of tangent is secant squared, but that's not knocking this out. That's not getting rid of the other secants and stuff, so you're stuck. And then I said, you know what, let me turn everything into sine and cosine. Convert everything into sine and cosine, and it turned out that it worked out well, because what do we have here? We have 6 over sine to the cosine to the 6th times what? We have sine over cosine, right? So we have 6 cosine to the negative, like theta to the negative 7th times sine theta. Well, that's easy now, because what's the only thing we need to do? Oh, actually, I'm sorry, x over 4. And then the last thing is just let u equal cosine of x over 4, and that means du over dx is equal to negative 1/4 sine of x over 4 and then you simply now have an integral of 6 u to the negative 7th sine x over 4 times du over negative 1/4 sine of x over 4. Final answer, you have the integral of 6 u to the negative 7. Actually, what is it? Negative 24. Yeah, u to the 7 du. ... And that's basically it. So, try these problems. Go through it slowly. Look to.
Whoops. So 1, 2, 3, 4, 5.
Look for, when look to see if the substitution will knock out something else, or look to see if they give you a substitution.